Hello guys, welcome back to my YouTube channel. Myself Megan MJ, a computer science and engineering student from Sri Venkateshwara College of Engineering, Bangalore. Today I'm going to discuss about the subject is discrete mathematics structure. The topic is basic connectives and truth tables, logic equivalence in discrete mathematics structure. Introduction to basic connectives. Basic connectives are foundational elements in propositional logic. They help in constructing complex logical statements from simpler ones. Understanding these connectives is crucial for analyzing logical relationships. And these are some words or symbols used to combine two sentences to form a compound sentence. And the words are negation, conjunction, disjunction, conditional, and biconditional. Types of basic connectives. The primary basic connectives include and, or, not, implies, and biconditional. Each connective has a unique function and the truth value assignment. These connectives form the building blocks for more complex logical expressions. And the connectives are adding, sequencing, emphasizing, comparing, cause and effect, qualifying, illustrating, constructing. The and connective, or it is called a conjunction. The and connective denoted as the symbol yields true only when both operands are true. It is represented in truth tables as a combination of true and false values. For example, a expression A connective B is A and B is true if both A and B are true. The truth table shows how a conjunction between P and Q would look. It is only true when both P and Q are true. It is false when either P or Q are false. The OR connective, or it is called disjunction. The OR connective denoted by OR symbol is true if at least one of the operand is true. In truth tables, it allows for more flexibility compared to AND connective. The expression A or B is false only when both A and B are false. The disjunction of prepositions P and Q is denoted by P or Q has a truth table. If P denotes I'll go to the gym and Q denotes I watch TV, then P or Q denotes the I will go to gym or I watch the TV. And the next connective is not connective, or it is called negation. The not connective represented as the negation symbol in it means inverses the truth table of its operand. If A is true, then negation A is false and vice versa. Negation is crucial for expressing the opposite of logical statements. And these are some two truth tables for negation connective. And implication and biconditional. The implication connective represents a conditional relationship between two statements. A biconditional connective indicates both statements are either true or false together. These connectives allows for more nuanced logical expressions in mathematics. Expression of implication. If P then Q, Q if P. P only if Q, P is sufficient condition for Q, and Q is necessary condition for P. P is called the hypothesis or antecedent, and Q is called conclusion or consequent. And the truth table overview. A truth table systematically presents the truth values of logical expressions. Each row of the table corresponds to a unique combination of operand truth values. Truth tables are essential for verifying the validity of logical arguments. And the truth tables are used to show or define the relationship between the truth values of the individual propositions and the compound propositions based on them. The constructing a truth table. To construct a truth table, list all possible truth value combinations for the variables, calculating the output for each logical connective based on the combinations. This method provides a clear visualization of how the expression behaves under different scenarios. For example, truth tables construct a truth table for negation P and Q. Step 1. First, list the simple statements on the top and show all the possible truth values, and make a column for P and Q and fill it in the truth values. The logic equivalence. Logic equivalence occurs when two expressions yield the same truth values across all scenarios. Equivalent expressions can be used interchangeably in logical arguments. Understanding equivalence helps in simplifying complex logical statements. Logical equivalence, the definition, the compound propositions P and Q are called logically equivalent. The P is and Q is a tautology. The notation P Q denotes that P and Q are logically equivalent. Compound propositions that have the same truth values in all possible cases are called logically equivalent. And conclusion and importance. Mastery of basic connectives and truth tables is essential in discrete mathematics. These compounds concepts underpin foundational reasoning in both mathematics and computer science. A solid understanding of logic equivalences enhances problem solving skills in various fields. And the logic connectives of like formal names, negation, and this is a symbol. In negation, we can read it as not. Conjunction is and we can read distinction is or, and conditional is if then, if and only if is biconditional. Thank you for listening. Hope you all understand about the concept. Thank you.